Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss 7 primitive unit cells and their possible variations as centered unit cells. Last class I have discussed primitive and centered unit cells. Now I am going to discuss 7 primitive unit cells and their possible variation as centered unit cells. Here what I discussed last class, now here I am going in details. Here I will discuss with example. I will discuss with examples all 7 structure. And in that structure, this primitive, body-centered, face-centered, that I will discuss. Also, I will discuss axial distance or edge length. Means all edges are equal or not, that I will tell. And also I will tell axial angles. What are the angles? Means value of alpha, beta and gamma, and examples. This I will tell for all 7 structure. Okay, 7 primitive unit cells and their possible variation as centered unit cells. First I told the structure, that was the cubic structure, cubic crystal system. In that 3 possibilities are there. Primitive will be there. First possible variation I am telling you, possible variation, then it will be primitive. It may be body centered, it may be face centered. 3 possibilities are there. Means particles will be arranged on each corner, or on each corner particles will be arranged. When it is arranged, means 4 up and 4 down. In cube, 4 corners up, 4 corners down. There particles may be there. Particles may be atom, ion or molecule. Then on each corner one particles may be there. If it is there, then it is called primitive. Already last class I discussed. And body centered condition, you know, that in each corner it will be, that is a certain. And after that, in the middle, 1 particle will be there. In the middle of the body, 1 particle will be there. This is the second possibility. And third possibility is that on each face, 6 faces are there in cube. Then on each face in the center, 1 particle will be there. Hence, here in cubic, 3 possibilities are there. Then this I told you maybe primitive will be, and other 2 body centered and face centered is also possible. And what will be the axial distance? Means edge length. Then you know, in cube all lengths are equal. Means A is equal to B, B is equal to C. Length, breadth, height all are equal. That is called cubic. And angle, then angle will be all angle. Alpha is equal to beta is equal to gamma is equal to 90 degree. All are 90 degree. What are the examples of cubic crystal system? Then NaCl, zinc blende means ZnS, copper, etc. These are the examples of cubic crystal system. Question is asked. Now, second structure, tetragonal. Tetragonal. Then here you will find in tetragonal, primitive will be there, means on all edge, on all corner will be there one particle, and one more possibility is there in tetragonal, that is the body centered. One will be in the center of the body. And what will be the length? The length will be A equal to B. A equal to B and B is not equal to C. Means here how one is differing, one length is differing. A is equal to B, but B is not equal to C. A is equal to B and B is not equal to C. And what are the angles? Axial angles. Then here alpha is equal to beta, beta is equal to gamma, and gamma is equal to 90 degree. Means here also angle will be 90 degree. All angles will be 90, all three angles will be 90 degree. But difference is that here one side will be not equal to the other. Means A is equal to B, both are equal, A and B, but B is not equal to C. Means they are differing in height. Okay. And what is its example? Then its example is white tin, SnO2. SnO2 means stannous oxide, titanium oxide, calcium sulfate. These are the example of tetragonal. Example actually, generally examples they are asking, and conditions, all things, angle and sides. Then here in tetragonal example, white tin, SnO2, titanium oxide, white tin actually SnO2, titanium oxide, calcium sulfate. Now come to the third structure, orthorhombic. Orthorhombic. Here 4 possibilities are there. In tetragonal I told 2 possibilities. Here 4 possibilities. First case cubic was 3. Cubic was 3 possibilities, tetragonal 2, and orthorhombic 4 possibilities are there. Then first is primitive, second is body centered, third is face centered, and fourth is end centered. End centered, correct? And what are the sides? Sides. Then now here you can see no sides are equal, all sides are different. See, no sides are equal. A is not equal to B, B is not equal to C. Okay. And angles. Then here again all angles are equal, means 90 degree. Then see the differences. Now in 3 you have seen angles are equal, means 90 degree in 3 cases. Only in side it is differing. In orthorhombic, A is not equal to B, B is not equal to C. Sides are not equal, but angles are equal. And what is its example? Then its example is rhombic sulfur, potassium nitrate, barium sulfate. These are the example of orthorhombic crystal. Okay, these three example: rhombic sulfur, potassium nitrate, and barium sulfate. Now, fourth structure, fourth crystal system, that is the hexagonal, fourth one. And now here you can see, here only one possibility is there, that is the primitive, means only on the corner particles will be there. Okay, and here you will find A is equal to B and B is not equal to C, like second one, tetragonal. Like second one, same condition is here, that is the fourth one, hexagonal. A is equal to B, B is not equal to C. And what about the angles? Then two angles are 90 degree, means alpha is equal to beta. Alpha is equal to beta, beta is equal to 90 degree. And third angle is different, that is a gamma. Gamma angle is 120 degree. Means two types of angles are there. Alpha is equal to beta, beta is equal to 90 degree. And third angle, gamma is equal to 120 degree. And what is its this thing's example? Then its example is graphite, zinc oxide, cadmium sulfide, CDS, that is a graphite. Second is a ZNO, means zinc oxide. Third is cadmium sulfide, CDS. Then hexagonal, I told you, hexagonal, just by name it is clear, hexa means 6. It is just like a cylinder. It is just like a cylinder having 6 corner, just like a benzene. Up and down, just like a benzene. 6 sides are there in benzene. Then up and down, it is like that. And all if you will join, then it will become like a cylinder. Correct? Upside one is benzene ring, other side down benzene ring, and all side, all point you just corresponding point you just join it. All corresponding point you join it. Then it will become hexagonal. Just like it will look like a cylinder. But up and down, that is the 6 points are there. Up 6 points, down 6 points. Now fifth one I am telling you, rhombohedral or trigonal also. It has two names, rhombohedral or trigonal. Tetragonal I told you. Now it is a trigonal and other name is rhombohedral. Here again possibility is only one possibility is primitive. Hexagonal also one possibility is, rhombohedral also one possibility is primitive. And rhombohedral or trigonal, two names are there. Then here what are the sides? Then here sides are equal. A is equal to B, B is equal to C. Sides are equal, but sides and angles also are equal. Sides are equal, A is equal to B, B is equal to C, and angles are also equal, 90 degree. Alpha is equal to beta, beta is equal to gamma. Not two angles, they will differ in one angle. Alpha is equal to beta, and beta is equal to gamma, but angles are not 90 degree, maybe less or more. Actually, it is just like a cube, but only difference is that sides are equal, no problem. But angles alpha, beta and gamma, all three angles are not equal to 90 degree, maybe less or maybe more. See how they are differing. In angle they are differing. Angles are not 90 degree. All three angles may not be 90 degree. Less than 90, it will be not 90 degree, maybe less, maybe more, but not 90 degree. And its example is calcite. Calcite means calcium carbonate. And this Cinevar, HGS, Cinevar, its chemical name is HGS. And these are the examples of rhomohedral or trigonal. Then I have told you about five structure. Now I am telling you about the sixth structure, sixth crystal system, that is the monoclinic. Monoclinic, two possibilities. Monoclinic, two possibilities. First is that primitive is common. Primitive is common everywhere. Primitive. Then here, second is end-centered. End-centered. Here you have seen in tetragonal, two possibilities was there. The one is a primitive. Second was body-centered. But here, in the place of body center, it is end-centered. And what is its sides, edge? Then all edges are different. All edges are different. All sides are different. A is not equal to B. B is not equal to C. And angles. Then here angles alpha is equal to gamma. Alpha is equal to gamma. Height side. Alpha is equal to gamma and gamma is equal to 90 degree. Means two angles are 90 degree. And third, beta, that is not 90 degree. Beta is not 90 degree. Correct? Maybe less or more, but not 90 degree. Correct? Then it is easy to remember also alpha and gamma is equal to 90 degree. Alpha and gamma. And beta is not 90 degree. That's why all you can say, I told you that A's are 6, but see how they are, how means ABC, everywhere ABC are there, but they are differing in sometimes in sides, sometimes in angles. What is its example? Monoclinic. Then its first example is monoclinic sulfur. Second example is sodium sulfate. Third example, monoclinic sulfur. First example, two examples are there. First example is monoclinic sulfur, and second example is sodium sulfate, Na2SO4 10H2O. Two examples. Now, last system, crystal system, last structure, that is the triclinic. Triclinic. In triclinic, only one possibility is there. Primitive. Primitive only means every corner one particles will be there. Okay. And what about the sides? Then here also sides are not equal. Just like a monoclinic, here also sides are not equal, means in both conditions are same. In case of sides, monoclinic also sides are not equal, here also sides are not equal. Monoclinic, triclinic, both are clinic. Okay, mono and tri. And what about the angles? Then here all angles are not 90 degree. This is certain. Alpha is not equal to beta, beta is not equal to gamma, gamma is not equal to 90 degree. Means no angles are 90 degree. And what is example? Then its example is potassium dichromate, copper sulfate 5H2O, and H3BO3 boric acid, H3BO3 boric acid. 3 examples are there: potassium dichromate, copper sulfate 5H2O, H3BO3. This I have told you about the 7 structure, how they are different. We all have A, B, C. Total 6 sides are there, but they are differing in sides and angles. Okay, then now you can understand that 14 structure, all possible 14 structure. Now easily you can understand that. Also I am telling all 14. How it will become 14, then I am telling you now. Then here in case of this cubic lattice, I am telling you, there is a 3 possibilities. If you will count all, that cubic, I told you 3 possibilities. Trigonal, tetragonal 2, then 3 plus 2, 5, and orthorhombic 4, then 5 plus 4, 9, hexagonal 1, then 10, and rhombohedral again 1, 11, and again monoclinic 2, then 11 plus 2, 13, and triclinic 1. Okay, then total 14. You can say possible structures are there. Total 14. Correct? But they are differing. That is in cubic 3, in tetragonal 2, in orthorhombic 4, in hexagonal 1, and rhombohedral 1, monoclinic 2, and triclinic 1. Then total possible structure is 14. Cut. But this system is, crystal system is only 7. Crystal system is 7. Within that 7, in cubic 3, tetragonal 2, orthorhombic 4, correct, hexagonal 1, and rhombohedral or trigonal 1, and monoclinic 2, triclinic 3. Total 14. Okay, question is asked. Then I have discussed about the all crystal system and all possible 14 structure. I will try to send this diagram for all these things, structure. Already I have sent last class. Again I will try to send it. Now I am going to discuss number of atoms in a unit cell. Number of atom in unit cell. Here you will think that what is this? Already primitive, you know that every corner one particle will be there. Then it will be 8. But now it is not like that. In a particularly in cubic, you may think that is the 8. Every corner one is there. Then 8 corners there. 8 will be there. But now we have to understand in each unit how many, in each unit cell how many atoms are there. That calculation is different. Why it is different? because in any crystal only one unit will be not there. Only one unit will be not there. It is joined with surrounding many units are there. In a crystal many unit cell will be there. Up, down, left, right, north, south. Direction wise I am telling you, north, south, east, west, up, down. Everywhere other unit will be there. Then some common will be there. Some particles will be common. May be present this side also, that side also. Upside also, down also. Left side also, right side also. North side also, south side also. Same because this unit cell, suppose it is in the middle. Suppose you consider unit cell in the middle. Upside other unit is there. Down other unit is there. North side other unit is there. South side other unit is there. Left east side other, west side other. Everywhere unit cells are there. In the center you consider one unit cell, but I told you many unit cells are may be there. Then upside also one unit cell may be there, down also, north side also, south side also, east side also, west side also. Then every corner particles will be common everywhere. Correct? Eight particles are there. These 8 particles are also common in neighboring cell, unit cell. These things you have to understand. All 8 particles are common with surrounding, neighboring with neighboring, I can say, unit cell. Correct? This you have to consider, and this diagram what I told you just consider, imagine this type of situation, that one unit is joined by other 8 unit cell. Correct? Up and down, that is 2. Now north and south, again 2, then it became 4. Now up and down you have counted, north and south you counted, east and west you have to count. Then all 8 particles are common with other 8 corner, other unit cells corner. It is shared. Okay. Then now all 8 are sharing other 8. Correct? This you have to consider. Then number of atoms in a unit cell now I am discussing. Okay. We know that any crystal lattice is made up of very large number of unit cells, and every lattice point means a structure, each point, every lattice point is occupied by one constituent particles. Particles means, already told you, maybe atom, molecule or ion. Now let us now consider portion of each particles belongs to a particular unit cell. Okay, that we have to think now what portion of each particle, atom you are talking about, what portion of each particle belongs to a particular unit cell. Now here we will consider three types of cubic unit cell. Three types of cubic unit cells, and for simplicity we will assume that the constituent particle is an atom. Okay, we will generally whatever we will discuss in that we will consider particles are atom. Okay, and in these three types of cubic unit we will consider. Then now just to consider primitive cubic unit cell. Correct, means each corner cubic means 8 corners are there. 8 corners are there, and every corner one atom is there. That we have to consider. Then primitive cubic unit cell has atoms only at its corner. Each atom at a corner is shared between 8 adjacent unit cells. Correct? Already I briefed you that each atom at a corner is shared between 8 adjacent unit cells. Okay, 4 unit cells in the same layer. I will try to send this structure also, but now what I told you, just imagine, that is the best. Okay, then that you consider that now any one atom you consider, only one atom, one corner is there, that you know, that atom is, you can say, common with 8 adjacent unit cell. Only one atom you consider, not 8 atoms. Only one you consider, one atom, and this atom is sharing with 8 unit cell. Okay, 4 up and 4 down. 4 up and 4 down. Okay, and means total 8. It became total 8. Then one atom is sharing 8 unit cell. 2 upside and 2 down. 4 upside, 4 down total. Okay, then just you imagine only 4 cube you just joined. Consider 4 cube, total 8 cube, 4 up and 4 down. Just you imagine, all are joined. Then you think in the way when they are joining, all 8 are joining, 4 you keep down, 4 you keep down, and 4 you keep up. Total 8. Then in the center only one atom you consider. One atom is there. Then now this atom is sharing 8 unit cell. 8 unit cell adjacent. Means one atom is common with 8. This is the important point. Then what will happen? Then there because one atom is sharing 8, therefore only 1 upon 8 portion you can tell, or only 1 upon 8th of an atom or molecule or ion is actually belonging to a particular unit cell, because one is sharing with 8. One atom is sharing with 8 unit cell. Then with 1, how much? 1 upon 8. 8 for 8 unit cell, 1 atom is there. Then for 1 unit cell, 1 upon 8. Correct? Then this is the actual situation. Only 1 upon 8th of an atom belongs to a particular unit cell. Okay, a primitive cubic unit cell. In that you can understand like this only. I think now you understand 1/8 or 1/8 of an atom is we can say this 1/8 of an atom is an atom belong to a particular unit cell. Now again further that you understand. This actually is called open structure. Each a small sphere you can consider, atom you can consider as a small sphere every time. Okay, atom you can consider as a small sphere every time you consider. Then here this each a small center means I am talking about the one atom only. Each a small sphere represents only the center of the particles occupying that position and not the actual size. Okay, one atom only a sphere you are considering, a small sphere. Such a structure, this type of a structure, when you are considering only one atom sharing 8 unit cell, this is called open structure. The arrangement of particles is easier. To follow the open structure. Okay. Now I am telling you important things here. Actually you can understand in a three diagram will be there always. I already told you that cubic only 3 type of cubic you have to understand. Then one type that is ordinary cubic. Ordinary cube structure you have seen. Ordinary cube structure like that way, each corner 1 8 corner 8 sphere. 8 sphere, small sphere. A sphere indicates atom. This is one type of structure. Other type of structure you can understand just 4 sphere down and upside again 4 sphere. Total 8. This is the second type of cube. 4 sphere down and upside again 4 on each other. 4 down, 4 up. Total 8. This is the second type of cube representation. And third type, if you will think, if you will consider only portion, which is common, which is coming under one cube, then that just only portion you have to cut it, and what is a common, only that structure you can see. Only from this 8, what I told you, 4 down, 4 up, only common portion just you consider. Which is going outside, leave it. Cut it. Only what is common, that you just, if you will consider that, if imagination you will do like that, that only common, which are the common, only that diagram you can consider. That size you can consider. That shape you can consider. That is the third type. Then all three actually it is in the form of cube only. One is just on just like each corner one sphere you have kept. Other type just 4 sphere you have kept, 4 down, 4 up, total 8. And third structure, that same what you have written 4 up, 4 down, in that you common things only you just consider. resting, you cut it, it will look like a cubic structure only. Then this three type of structure I have told you. First structure that is a distance open structure. When you will consider on cube, on each corner one particles are there, then that is called open structure. And second structure, what you told you, 4 down 4 up, that is called a space filling structure. A space filling structure. And third type, that is called actual portion, because you are talking about the common portion. Then that is called actual portion of atoms belonging to one unit cell. Then these three type of cubic structure I have told you. And here one more things I want to tell you, I want to highlight it, because that is very conceptual and you have to think that things. What is that? If all a sphere, this 4 up and 4 down sphere, if we will keep all spheres 4 up and 4 down, then what will you see? That you will find that between the spheres in the middle, in the center, one gap will be there. Correct? Between the all 4 up and 4 down, everywhere 4 you can count. 4 up and 4 down, just you think in a space you are keeping 4 up and 4 down. Then in the center one gap will be there. In the center one gap will be there. Means upside one gap, down one gap, north side one gap, south side one gap, east side one gap, west side one gap. This gap, always you remember, actually this gap is called void, void, void. Question is asked. Main things I have told you in diagram, in different diagram, this gap, it will look like a you can say triangle. If you will join, you can say this gap, if you will join, it will look like a triangle. Correct? It will look like a triangle. Then this down, suppose you are making one line, okay, one line, and again upside, just like a triangle, it will form like a triangle. Okay, if you will join all, then it will look like a triangle. Upside means upside, if you will join, then it will be one triangle. Down, if you will see, because in a space you are talking about, that all are in a space, so you can see down also. That type of situation you have to consider. From the earth upside, you have to consider. It is there, hanging like that, you have to imagine. Then upside one void, then one triangle. Down one void, one triangle. North side, one triangle. South side, one triangle. East and west, one triangle. Means total how many void are there? 1, 2, 3, 4, 5, 6. 6 voids. 6 triangle you will get. These important points only I briefed you, because in this chapter you have to focus on these things also. Okay. These are the very, very important. Actually, here in this chapter you will study how atoms are arranged. That you are studying actually. How atoms are arranged. Okay. Then again I am briefing you important point only, that how atoms are arranged. Atoms means here you are considering a sphere, just like a football you have seen, a small, very small football you can consider, that is just like a sphere. Okay, ball, a small ball you can tell, that is called a sphere. Then a small, very small ball you can consider as an atom. Then now in a structure, how these atoms are arranged? This ball may be atom, maybe ion, maybe molecule. Okay, then how these are arranged in crystal, that you are going to study. Okay, then one thing I am telling you, I am giving idea, exact I will tell you, but now just main things I will brief you. That it can arrange, you can say, first arrangement, maybe you can say a straight line, one dimensional. A straight line means one ball, then second ball, third ball, fourth, 5, 6, and all are touching to each other. Correct? Then that is called one dimensional. Only length is there. One sphere, other sphere, third, fourth, fifth, all are in a straight line, a straight way arranged, touching to each other. Then this is called unidirectional, monodirectional or unidirectional, one dimensional, one dimension, only length. This is the one possibility, a straight way only, one dimensional. But now you can think that in any crystal, only few atoms will be not there, many atoms may be there. Then second possibility is that again second row also you can start touching with first row. Now second sphere just in parallel to the first, can say arrangement. Second row also you can arrange, second also, third also, fourth also. Just like in one row 5 you have kept, second row again 5, third again 5, fourth again 5, fifth again 5, total 25. Correct? And all are parallel. Then total 25 arrangement is there. Okay, 5. Then now here it is called two-dimensional. It is called two-dimensional because length is also there, breadth is also there, 5 into 5. 5 into 5. Suppose 1 centimeter was the diameter for one sphere, diameter. Then 5 ball means 5 sphere means 5 centimeter, or down also 5 centimeter. Each suppose all our spheres are equal. Then 5 into 5, length is 5 centimeter, breadth is 5 centimeter. Then this is an example of a two dimension, length and breadth. Now third example, that is the three-dimensional. And in three-dimensional, you know that height will be also counted, depth or height, anything you can consider, height or thickness you can tell, that also will be considered. Then now suppose only now length and breadth you have seen, two-dimensional. Now above this again you can arrange. Again 25 you can keep, 5, 5, 5 above first layer, second layer also you can keep, third layer also you can keep, fourth layer also you can keep. It means 4 layer means 5 into 4, 20. Correct? Then this is the third arrangement. That is a three-dimensional structure. Then you understood first dimensional, second dimensional, third dimensional. Now again just only in this minor change I am doing, minor change. That now all sphere you have arranged in a parallel way. But now you think that you are arranging one above other. Five ball you have kept, correct? 5 ball you have arranged unidirectional, means one dimensional. Now you want to keep that is the upside means on this 5 sphere upside second you want to arrange second you can say row you want to arrange in the first row. Above the first row you want to arrange second row. Then first things already I told you, one above the other in a parallel way. But now second possibility is that between the gap of two sphere upside you can keep one. Means every time between the gap of two, correct, there you can keep one. Then like that way wherever two sphere is meeting, above that one you can keep, correct. Means between the two sphere upside you are keeping one sphere, correct. Not on the same way, head to head, no head to head. That is the first category, head to head arrangement. Now you are keeping between, when two spheres when they are touching, there you are arranging like that way. Then this is the different type of arrangement. Then this same situation you can do that file just like what I discussed, 5 rows down we have kept, and second layer now you are arranging only between the gap, wherever spheres are touching, only there you are keeping, correct. Like that way arrangement also you can do, where two spheres are touching, there that side only you can keep. Then that is the extra type of arrangement. Then here two types of you can tell, when you will keep one above the others, then suppose five spheres you have kept head to head. In the beginning what I told, head to head 5, or then you will call A, because same arrangement you have done, head one above other. Then five rows was there, then 5 A you can tell. But if arrangement you are differing, means one above the other you are keeping, but now you are arranging in between the where both are touching, there you are keeping, that arrangement you are doing. Means A arrangement is one type, B arrangement, A is the same like first one what I discussed. Now above you are writing, it is not head, you are keeping on the where two spheres are touching, there you are keeping upside one. Like that way other also you can keep upside, again others also like upside. Then that is the another layer that you can tell B type. Other layer above first one, another layer is there, that is the arrangement is differing, between the gap you are keeping, that is the B type. Again suppose you are repeating with first one, A type, okay. Again B type, means where both are touching, that gap you are started with that. Then A type arrangement, B type, again A type arrangement, again B type arrangement, correct. Then this type of arrangement can be done. Then I think now you are understanding what I wanted to tell, okay, arrangement. Then these things are actually, it is discussed in a different form, and that terminology has been given, different terms has been given, okay. Then now one by one I will tell you. Then here what I have discussed now, you will find, I have briefed you actually. This is discussed in details. This is discussed in details, different terms has been given. Okay. Then now I am going to tell these things about that things only. I will tell you that thing that will come later on, but now I was discussing about the number of atoms in a unit cell. Then 1/8 you have understood that each cube has only 1/8 of an atom. Each cube. Then in if you will consider 8 cube, where one unit is completely one particle is occupying, then to occupy full one atom, then 8 cube is required. 1 atom is sharing 8, but 1 cube has 1/8. Then 8 cubic cell how much? 8 cubic cells how much? 8 into 1/8. 8 into 1/8. 8 cubic cell. 1 cubic cell is 1/8. Then 8 cubic cell how much? Then 8 into 1/8. That is equal to 1 atom. Then in all, since each cubic unit cell has 8 atoms, each cubic cell has how much? Cubic cell has 8 units. Each 8 corner. In all, since each cubic unit cell has 8 atoms on its corner, then the total number of atoms in one unit cell is 8 into 1/8. 8 into 1/8, that is a 1 atom. 8 into 1/8. 8 will cancel 1 atom. Then if we will consider complete, because what I discussed, that is only 1 atom you consider, but each corner in unit cell, total 8 atoms are there on each corner, 4 up, 4 down. Then if you will consider 1 atom, consider 1/8, then 8 corners. 8 corners means 8 into 1/8. That is equal to total 1 atom. Again I am telling you, since each cubic unit cell has 8 atoms, cubic cell, 8 atoms on its corner, the total number of atoms in one unit cell, that is the 8 into 1/8, that is the 1 atom only, not 8, only 1 atom. Correct? Because they are sharing with others and they don't have full right. They don't in any suppose path, any path in front of your house, if 10 feet is there, then 10 feet is common for both. You can't tell 10 feet is mine. Like that situation is here. 5 feet you can consider. Because only 2 are there, that side, this side, then you have divided by 2. But here 8, they are surrounded by 8 units, sharing with 8. Correct? That's why this total number of atoms in one unit cell is 8 into 1/8, that is the 1 atom. This the basic things I am telling you, that each cubic cell has a right only for 1/8. 1 atom. Okay, then total 8 atoms are there. Then each atom 1/8. Then 8 atom, 8 into 1/8. That is the 1 atom only. Then this I have told you about the primitive cubic lattice cell. This will happen, what I told you, in a primitive cubic unit cell. Now I am going to tell you about the body centered cubic unit cell. Body centered and face centered, like that I will discuss. Then now you are understanding primitive, I told you, one atom only. Like that way, body centered cubic lattice. Then you know that in this body centered, automatically primitive will be there. Then in primitive you know that only one atom will be there, and here in body centered one atom is in the center. One atom is in the center. Then here how many, you can say, this atom will be there in body centered cubic unit cell? Then here one body center atom has each body center has only one atom in the center, body center. Hence here you can tell each body centered cubic lattice, cubic unit, each have one. Then now total how many atoms are there in body centered? Then one due to primitive, and one due to body center, means total 2. 1 plus 1, 2. Total number of atoms per unit cell in a body centered cubic unit cell, that will be 2. Question is asked. First I told you 8 corners, primitive case, 8 corners into 1 upon 8, that is the 1. And second, extra 1 into 1 you can tell. Each cubic center 1. If 10 are there, then 10, 15 are there, then 15, 15 into 1, but only 1 you are considering here. Then 1 into 1, that is the 1. Then total became 1 plus 1, 2. Now just same way, basic is same to consider the face centered cubic unit cell. How many atoms are there in face centered cubic unit cell? Then now again easily you can understand, each face, on each face one atom will be there in the center, and primitive will be common. Then here, due to the primitive, means 8 corners atoms into 1 upon 8, that is the 1, already you know, that is the common. And here how many faces are there? Your cube you are considering, cube only, in cubic structure all things are studying. Then 6 faces is there, means 6 faces is there, then 6 atom will be there. Then 6 face centered atoms. And here you have to, because that 2 are in the front, as for example north, south, each are in the front, correct? Only they are sharing with 2 only. 2 sides are just here you have to understand, was equal are there, na? Sides, faces, 2 faces, left, right, up, down, direction wise, north, south, 2 faces are there. Correct? East face, east, west, 2 faces are there. Up and down, 2 faces are there. Then all 6, there are actually 3 faces are there, that is repeating. Correct? Just like in a square, 2 front are equal. In rectangle also you have seen 2 length and 2 breadth are equal. In rectangular, 2 length is equal, 2 breadth is equal. Here also you have to consider like that way. That why faces are 6, but they are repeating. Correct? 2 lengths are equal, 2 breadths are equal, 2 heights are equal. Means 3, all are equal. Then in that way you have to 6 faces are there. Then 50% sharing will be 50%. Correct? then 6 face-centered atoms into half atom per unit cell. Half atom per unit cell. Correct? Just like you have seen in full cube, 8 corners were there. 8 corners. Here 8 corners we are sharing with other 8. Each corner was sharing with other 8. Then here, like that way, 6 faces are there. Then front to front you will count. Then 6 faces center, 6 face centered atoms into half atom per unit cell. Half only, because you are talking about front only. Half. This you have to remember. Half. Then 6 into half, that is equal to 3. 3 atoms. 3 atoms. Then here again 3 plus 1, total will be 4. Okay, total will be 4. Okay. Then this is a number. Here you think, always you think that there will be not only one unit cell. There will be not only one unit cell. Many unit cell will be in the neighboring. Here in face centered also, that face center will share with others. This face center, one face you consider, then other neighboring unit cell will be there, it will share with that. Correct? That's why it is half. Every side other unit cell will be there. Then that face centered, that will share with other neighboring. That's why you are dividing by 2. Then now here you have seen 1 plus 3, that is the 4. Total number of atoms per unit cell is equal to 4 atoms. Correct? Then this I have discussed. This question is asked. Now I have discussed all the things. Now what I have discussed, that is the arrangement. That will take a time. Many terms are there. Then, but what I discussed now, arrangement, about the arrangement, void and this, that, only that will be discussed with many other terms. Then that I will discuss next class, because today it is not possible. It will take more time. Thank you.